let's talk about some homework questions from chapter 1.4, one-sided limits. Question B says, what's the limit as rho goes to 1 from the minus side of rho over 1 minus rho? First thing you might try doing is plugging in 1. What do you get? You get 1 over 1 minus 1, which is 1 over 0, which is undefined. Should we give up? Should we try something else? Maybe graph it. So as it's 0 here at 0, as you get closer and closer to 1, this is shooting off to infinity. So we'd say the limit as we go to 1 minus is dne, the infinity kind. If I graphed it over here, I would see a curve doing that, but that doesn't mean that there's a negative infinity kind of answer to this problem, because this problem is only concerned with coming in from the left. So we're starting below 1 and increasing there. Someone else asked about QA, which is about the max of 0 and x function. So it's our ramp function. Here's 0. Here's y equals 0. It's not actually meant to be tricky. It's just relatively straightforward. What's the limit as x goes to 0 minus? That would be coming in from the minus side here. And what's the behavior of the y values as you try all these negative x values? You just get y equals 0, y equals 0, y equals 0, y equals 0. What's the y destination of all those values? Well, you're getting 0, 0, 0, 0, 0 for all the y values, so it's just 0. How about the limit as x goes to 0 plus? There you're kind of coming in this way, and you're getting y values of like 10, 9, 8, 7, 6 if you're just doing the integer x values. And so that's also 0. So it's just a reasonably common piecewise function, and the behavior looks different, and in the global picture of behavior is different, but the behavior of the y values, what destination they're heading towards, is the same from both the left and the right. So we can say that overall the limit as x goes to 0 without the plus or minus is still 0. One of the questions was f of x equals absolute value of x over x if x is not 0, and 0 if x equals 0. So it's a pain to graph that on Desmos. You have to think about the piecewise way to define piecewise functions in Desmos. Here's what it looks like mathematically. You have a plus 1, y equals plus 1 here. You have y equals minus 1 here, and you have y equals 0 there. Have you ever seen this function before? This is the sine function, S-I-G-N, where if you give it sine of x, if you give it a positive x value, you get back positive 1. If you give it a negative x value, you get back negative 1. If you give it a 0x value, you get 0, because 0 has not a positive sign, not a negative sign. So what's the limit as x goes to 0 of this function? Not plus and not minus, just 0 without the plus or minus. That's dne, because it's a left-right mismatch. Can we say that the y value being 0 at 0 kind of rescues it? Nope, because remember, for limits, we are deliberately not looking at, oh sorry, I forgot, this is x equals 0 right here. We're deliberately not looking at what the function value is at the x value that we're approaching here. So even though f of 0 equals something that seems to be reasonable, it's kind of the average between those two things, that's not enough to rescue the left-right mismatch.